Hi, AP Calculus students. Welcome to section 4.5a, solving integrals with substitution. And here's our examples. We have 3 examples, and I will also put up 3 more. My black markers are kind of on the out, so I'm hoping the purple shows up well. Here we go. So you have your notes in front of you on the steps to using U substitution. So please follow those as I speak about how to do this. Okay, take a look here. This was on our notes video, right? And notice what we have here. I'm just checking these curtains, see if I can, a little bit better. No, it is what it is. Okay, okay, let's take a look. The first thing we do is we find an inside function that or a product, a factor, or a denominator who I see. If I took the derivative of that function, I see it being multiplied in a closed form. Okay, so I do see an inside function of x squared plus 1. Okay, so I am going to make my u in x squared plus 1. And I also see then that when I take the derivative of this expression, right, that I get 2x dx, again, because I am taking the derivative with respect to u. So I have to have the dx for a perfect substitution, and by the chain rule, it needs to be there. Okay, so I just checked. Do I have everything I need to do a complete u substitution? Yes, I do. This will be u to the 4th. My 2x dx I will replace with a du. Okay, so perfect substitution, perfect replacement here and here. Let's go ahead and do that. So this is u to the 4th, right? I took care of this, right? And I have a 2x dx left, and that is exactly equal to du. Okay? All the x's have been replaced with u's. Just checking again to see if you can see my purple. I think you can. Okay, so let's see here. I do know how to integrate u to the 4th. That would be a plus 1, right? And then I would divide by the new exponent. So now that I have integrated, I will write my integration. I will not forget my c. And now that I have integrated, I can replace, right? They started off with an x expression for my integrand, and that is what they want from me after in my final answer. So I will replace u with x squared plus 1 to the 5th over 5, or times 1/5, plus c. And here is my final answer. Now, how do I know if I'm correct? I know I'm correct because if I take the derivative here, I get this expression back. Take a look. If I were to take the derivative, I would bring the 5 out front and multiply it, and it would cancel. I would reduce the exponent by 1, it would be a 4. And then, of course, by the chain rule, I would multiply by the derivative of the inside function, which would be a 2x. And I would have the correct expression back. Okay, let's try that again with this expression, 3x squared times the square root of x cubed plus 1 dx. I think I can see pretty clearly an inside function of x cubed plus 1. I check when I take the derivative of it, that will be a 3x squared. So I do see the du being multiplied. Okay, so I believe my u is x cubed plus 1. And now du is simply just taking the derivative of u. You're not looking up here anywhere else. You're looking right here. And that derivative would be 3x squared. Don't forget your dx. Now, do I have perfect substitution into the expression? I do. I see an x cubed plus 1. I see a 3x squared dx. Let's go ahead and substitute, making sure that we've gotten everything. I usually substitute my u first. So this will be u, the square root of u, right? So I've taken care of this. This is the square root of u. 3x squared dx, right, is du. There we go. This I know how to integrate, right? So if it's okay with you, I know to use the power rule, I'm going to make this u to the 1/2. There we go. Now I'm going to go ahead and integrate. I'm going to add 1 to the exponent and divide by the new exponent. Okay. Rather than divide by 3/2, I'll multiply by 2/3. U to the 3/2 plus c. Notice I have integrated. I'm done. And this means that I can, for my u, put my x cubed back, x cubed plus 1 back in for u. Again, they started with an x expression, and they are expecting an x expression when you are done. Again, how would you like it if you had dollar bills and someone gave you pesos, right? No, you want the same thing back, right? Again, how do I know I'm right? If I took the derivative here, I would bring the 3/2 out front and multiply it. It would eliminate the 2/3, right? And I would reduce the exponent by 1. So I would have a 1/2 x cubed plus 1 to the 1/2. Then I would take the derivative of the inside function, which is 3x squared by the chain rule. Okay, let's take a look at number 3 over here. Let's take a look. We had talked about this in the other problems for the notes video, because here I kind of have to look. Sometimes you kind of have to play around with a little bit. What if I made u secant squared? Or what if I made u secant? Nope, the derivative of that would be secant times tangent, and I've got that plus 3 hanging out there, you know. So it's okay to not be right the first time. What if I made u secant squared, right? Then let's see, by the chain rule, when I take the derivative, I would have 2 times secant times secant times tangent. Wow, that's a mess. So let me try this. How about if I make my u tangent x plus 3? So I just want you to know that it's okay if you misidentify the u, right? And then you get a du that isn't helpful to you if you misidentify the u, right? And it's okay to change that, right? Sometimes it just takes a little bit of getting used to the pattern and a little bit of practice. On harder problems, I'll sometimes pick a u that wasn't the right expression, and I'll go back and pick a different one. Now, something I want to point out on this problem, though, is that, yes, absolutely, the derivative of tangent is secant squared, right? But to make an even simpler expression, you want to scoop in everything you can, right? And what I'm saying is tangent x plus 3, the derivative of that is also secant squared. So let's get that in there too, so we have a simpler expression. One of the mistakes students will tend to make is making u too much so that your du doesn't match the factor that you see. Again, that's okay. We'll get good at that. Okay, so our du then is secant squared dx. All right, let's see. I believe we have an exact substitution here into the integrand, which I forgot to put. We're actually integrating. There's the integrand. Let's see how we did. Can we replace everything with u's? I usually start with my u. Here's u, right? And secant squared dx, I will replace with du. Wow, look at how nice and easy that is, right? So I'll add 1 to the exponent and divide by the new exponent. And now I have u squared over 2 plus c. Now that I'm done integrating, I will replace my u with the x expression. So if it's okay with you, let's just, rather than keep rewriting it, tangent of x plus 3. And I guarantee you, if you take the derivative of this expression, you will get this original expression back when you use the chain rule. Okay, let's erase this and let's try some more. Because how can this get harder? Of course it can, right? But don't worry, not that much harder. Okay. All right, let's see if this blue marker works. No, that's not dark enough. Okay, here we go. Let's try, this is problem number 4. Let's integrate, let's see, I did 1, 2, 3. Oh, let's try this. Integrate 2x sine x squared dx. I'm sorry I keep changing markers. I actually need new ones and they're just not showing up dark enough. Okay, now this is one where students will be tempted to make u sine of x squared. And I get it, right? You want to do that. But notice when you take the derivative of sine of x squared, you would get cosine of x squared times 2x, and I don't see a cosine being multiplied here. So I think maybe I should go a little smaller. Is there an inside function? Yes, the x squared. Let's go a little smaller. Let's make our u x squared. It is an inside function. My du then is 2x dx. Okay, that's much better. I see the 2x right here. I believe I can do a perfect substitution with all u's. Let's try it. So this is going to be sine of u, and the 2x dx I will replace with du. Okay, notice that I tend to underline to make sure that I didn't miss any part of the integrand, that it is in fact a full u substitution. Now sine of u, I know how to integrate, right? The integration of sine would be a negative cosine of u plus c. Am I right? Let's take a look. When you take the derivative of cosine, you get a negative sign. So now it's a positive sign. Good. I integrated and now I can put my u back in right here. And again, notice that I could take the derivative here and check it. Let's try a 5th one. And what do we have here? Let's see. X cubed over 1 plus x to the 4th squared dx. Okay, what's going on here? Let's take a look. Okay, generally we want to replace a denominator. And the reason for that is that when I have a u expression and I take the derivative of it, right, I will get a du. That du is in the numerator. Like I can't have a du in the denominator. So this is why we are usually looking at denominators. Now, notice if I make my u though, right, it's easy to scoop in too much. If I make my u the whole denominator, notice this means I would bring the 2 out front and multiply it to get my du. So I would have 2 times 1 plus x to the 4th. Then I would have to take the derivative of the inside function, which is 4x cubed. I don't have all of that here, okay? Again, u is typically just an inside function. 1 plus x to the 4th is inside the squaring function in the denominator, okay? Let's see how this works for us. Now, my derivative then would be 4x cubed dx. Okay, well, this is concerning. I do have the x cubed dx. I do see that, oh, but I have a 4, and I don't see a 4 in here. So my problem here is that I don't see a perfect substitution into my integrand. I see a perfect substitution here, and I see this perfect substitution, x cubed dx. I don't see the 4. What do? Get rid of it. Divide by 4. Right? We know how to move constants around. So what does this mean? This means when I see an x cubed dx, I will replace it with a 1/4 du. Right? That constant I know how to work with. I believe I have a perfect substitution. I usually do my u first, so this will be u squared, right? My x cubed dx, I am going to replace with a 1/4 du, okay? Now, if it's okay with you, right, I could put a 1/4 du here. Okay, great, I know how to do that, right? But we like an integrand to be super easy, right? So how about, right, if we keep the 1/4 on the outside of the integrand, right, we will get the same expression, and we have a 1 du, right? I need to fill this numerator with something. Now in the book, they will put a du right here. No, no, no. This is the integrand. I keep it separate. This is the differential of u. I do not put the du in the integrand expression. Okay. Again, you are welcome to carry that 1/4 along. If you do all your work right, you'll get the same answer as me. Okay, did I do a perfect substitution? I sure did. I took care of everything. Okay, I know how to integrate this. If it's okay with you though, 1 over u squared, I'm going to call that u to the -2. I'm going to add 1 to the exponent and divide by the new exponent. So my integration is a -1/4 u to the -1 plus c. Now that I'm done integrating, I can put my u right in here. My u is 1 plus x to the 4th. Again, if you took the derivative here, you would see that you have the correct answer. Okay, one more, number 6. Okay, so what if they have you do a little bit more? What if they have you integrate a differential equation? So let's say that they give you on number 6. They say find f of x. And they give you that the derivative of f, right, a differential equation, is sine of 2x times cosine of 2x. And they also tell you that f of pi o f has a point on it at pi over 4 and 1/2. So they gave you that information so that you can find the c. Now, just so you know, right here, there's like 3 different answers you can have here that are all equivalent to each other. Because take a look here. I won't make my u 2x because the du would be 2. And now I have the sine and cosine. I still have a product and I don't know how to integrate a product. So I need more. So notice that if I make my u sine of 2x, then when I take the derivative, I'll get 2 cosine of 2x by the chain rule. That works. But some other students may say, well, can't I take the derivative of cosine of 2x and get a -2 sine of 2x? Absolutely you can. In the end, that is perfectly acceptable, and you will have what is an equivalent answer, right? Okay, so, but I like to keep the negatives out of here. So let's make our u, we know that we have to integrate to solve. Let's make our u sine of 2x. Du, the derivative of sine of anything is cosine of anything, times the derivative of the inside function is a 2, and don't forget your dx. Okay, notice that here I see the sine of 2x, the cosine of 2x. I do not see multiplying by a constant of 2. That's okay, and I like a perfect substitution. Again, in your book will tend to change the integrand. I don't, I change what I'm working with right here. Okay, I think I can do a perfect substitution here now. So the integral of the derivative leaves me with the function. And that is, okay, let me substitute here. Okay, so this was my u, and my cosine of 2x I will replace with a 1/2 du. Let's make sure we got everything. Here's u, and cosine of x is a 1/2 du, right? So u and 1/2 du. Excellent. I know how to integrate this. I'll add 1 to the exponent and divide by the new exponent. So I now have f of x is equal to 1 in the numerator, and I have 2 times 2. I have a 1/4 in the denominator, right? And u squared plus c. Okay. Now that I have integrated, I'm going to replace my u with sine of 2x. There we go. Now, what the book has done is they have given me a starting point so that I can find the c. So let's go ahead and do that. They're saying when x is pi over 4, that the output is 1/2. So let's go ahead and do that. 1/2 equals 1/4. Let's find that c. When I put a pi over 4 right here, 2 times pi over 4 is pi over 2. Sine of pi over 2 is 1. 1 squared is 1. So I just have 1 times 1/4 plus c. And you can see, what would I add to 1/4 to get 1/2? I would add a 1/4. And so my final answer, though there's a few variations you might see, is right here. Okay, again, let's recap. They wanted me to find the function, and they gave me a starting point. They gave me the derivative of f was sine of 2x cosine of 2x. So I knew I had to integrate to remove this derivative. I did that on the left, and I got f of x. I did a u substitution here. My du, I had to clean up a little bit, so I had an exact replacement, right? I actually forgot my dx there. I carried the 1/2, I integrated. So I u squared over 2, had my constants here. So I had my f of x equals 1/4 u squared plus c. I put my u back in so that I could use this xy point to find the c. There. I hope you find it kind of fun. I do. Have a wonderful day.